When a user logs on to StepWise, they're able to see a history of previously asked questions on the left and some options for submitting a new question on the right. If a user comes to the platform without a specific question in mind, they're able to get a random one of some difficulty level and some area of mathematics with this option down here. But let's say we want to solve a specific fourth order polynomial today. So we can paste in the question that we want to solve and hit submit. So here, Stepwise will generate two possible first steps to solve this equation. And while that's happening, let's take a look at the user settings up here. So on the back end, we use API large language model providers to give us mathematical reasoning steps. And we allow the user to choose between one of four of these possible LLMs. We also have an easy mode and a hard mode that they can configure. So in easy mode, a student needs to choose between two possible nodes at each step. In hard mode, we bump that up to three. And we also introduce some adversarial nodes to make the problem solving a little bit more difficult. Okay, so now let's come back to the reasoning tree, and you'll see that Stepwise has proposed two possible first steps for us to go down. We use some complicated prompt engineering to ensure that these steps are going to be quite unique and different from each other. And let's say that looking here, I think that this bottom rational root theorem approach looks a bit more promising to me. I can tell Stepwise to continue to explore this line of reasoning by hitting accept. And while we wait for it to generate two more nodes for us to explore, let's ask it a question. So at any point, if a user has a math question about the reasoning that the system is taking, they can come over to this chat window and ask their question. The chat window will pull in information from the left-hand side, so it will ground its response in the polynomial that we're trying to solve. And because this is a chat interface, which is a little bit leaky, we have guardrails here to prevent the user from uploading sensitive information, and also to prevent the chat from simply outright revealing the answer to the math problem that we're working on. Great, so let's come back here. Now we have two additional possible steps that we can take. So we have this cubic factorization approach and this polynomial long division. I think to me, the polynomial long division looks a little bit more promising, but maybe let's nudge the system in one direction. So if we think that we know where the solution is going, we can actually nudge stepwise towards that solution with natural language feedback. When we provide this except with feedback, the system will adhere to that feedback as much as possible. You'll see it only generates a single node instead of two. Also, because this is a chat interface, we have the same guardrails as we do with our standard chat to prevent users from uploading sensitive information and to keep focused on the math problem at hand. So you'll see it finds that z equals 3 is indeed a root of this cubic equation. So now we found two roots, 2 and 3. Everything looks good to me so far, so I'll do one final expansion, and hopefully we'll get to a solution just by reducing this final quadratic equation. And you'll see that stepwise is able to get to an answer here. So when it reaches a terminal state, an answer state, it will flag that with this answer tag, and it will color that node either green or red. In this case, it's green because our solution is correct here. The roots that we've identified are the actual roots of the equation. If we scroll down on the solution state on the right, we can see why this is identified as green. And on the back end, when we submitted the question, we're also passing it back to our back-end math problem-solving system. And Ankit will talk about how that system works and how it's able to correctly answer these difficult math questions most of the time.